Okay, I think today's topic will be pretty easy as long as last week when we talked about stoichiometric calculations, as long as that made sense. You will need to do some stoichiometric calculations to set up this problem, but then we're just going to add one new piece of information, and that's called percent yield. So to introduce this topic, I'm going to give you a scenario. We're going to talk about an experiment that we could do. All right, here's a picture of what the experiment looks like. We're going to take copper wire. So this is copper wire that's wound up and it's in a beaker. And what we're going to do is we're going to fill that beaker with a solution of silver nitrate. So here's what the balanced chemical equation looks like for that experiment. So we have the copper, we have our copper wire here. Silver nitrate is what we're going to fill the beaker with, and you'll see that in the little video I'll play in a little bit. We're going to fill that with silver nitrate, and as you see, this is a single replacement reaction, right? So silver is going to get kicked out, and then we're going to end up with copper 2 nitrate and silver. So the reason this reaction is cool is because we actually produce silver metal. So you can actually make silver from this. And that's one of the reasons why silver nitrate is an expensive chemical, because it has silver ions, and you can do a reaction like this to actually produce silver crystals. It's really cool. So if we do that experiment, the way we're going to set it up is you need to be familiar with a couple terms. We're going to have an excess amount of silver nitrate. So that means I'm going to fill this beaker up with way more silver nitrate than we need. All right, we're going to have more than enough for whatever we want to do. The copper, though, is going to be limiting. So what that means is that the amount of silver we can produce is going to be limited by the amount of copper we start with. Okay, the silver nitrate has nothing to do with it because I've told you we have more than we'll need. Right, but the copper, we can figure out how much silver we can make based on the amount of copper we start with. Right. So we can figure that out using stoichiometry. So what we're going to do, let's say we start with a certain amount of copper. We'll take the mass of that copper, and using a mass to mass stoichiometric calculation, we can calculate how much silver we will make. What would be the mass of silver that we make, right? So let's go ahead and do that. I'm just going to show you since we went over this last week, but here it is. So let's say we start with 3.05 grams of copper. So that's the mass of the copper wire. We want to figure out the mass of silver that we can produce. So that's a mass to mass conversion. So first we convert grams of copper to moles of copper using its molar mass from the periodic table. Then we do a mole to mole conversion, converting moles of copper to moles of silver. That uses the mole ratio from the balanced chemical equation, so 1 mole of copper for every 2 moles of silver. And then lastly, we convert moles of silver to grams of silver using its molar mass from the periodic table. When you type that in, you do 3.05 divided by 63.55 times 2 times 107.87 gives us a grand total of 10.4 grams of silver. So if we do the experiment, we should get 10.4 grams of silver, right? So let's do the experiment. You can watch, there'll be a little video here. You ready? It'll be sped up. So we pour that silver nitrate in, and we start forming silver crystals. That's all silver. Side note, I've mentioned this before, but if you can figure out why the solution turns blue, good for you. Any thoughts? Look at what's being produced here. I mentioned this very briefly in a previous video on chemical equations when we were classifying chemical reactions. It forms copper ions, and copper ions are blue. You can watch that again. So we fill that with silver nitrate, and then the silver crystals form. So what we do is we take all those crystals out, we wash them, and then we take their mass, and after the experiment, we get 8.79 grams of silver. What? Right? We get not as much silver as we thought. Does this make sense? It should probably make sense. Most of you would probably guess that we would not produce the exact amount. And you'd probably also guess that we'd probably make less than what we predicted. There's a lot of errors that go along with chemical equations, chemical reactions, and then also some side reactions happen. In chemistry, most of the reactions are not 100% efficient. And so what chemists like to do is talk about what's called percent yield. We like to talk about when we do the reaction, what percentage of the product actually gets made based off of our calculations. So the terms you need to understand here are theoretical yield, which is the amount that we calculated. When we put in our initial amount of copper, we proposed that we could make 10.4 grams of silver theoretically, right? If everything were perfect, we could theoretically make 10.4 grams of silver. That's called the theoretical yield. When we actually did the experiment, we got 8.79 grams of silver. That's called the actual yield. All right, so these are the two terms you need to understand to calculate what's called percent yield. Right? If you can understand that and if you can do this equation, this will be a pretty easy topic. Okay, so percent yield, it's just the ratio of the actual yield to the theoretical yield. So you need to have both of those numbers. The actual yield, the amount of product produced in the experiment. So that's if you actually did the experiment, that's the amount you produce. Since you're not being asked to do the experiments in your homework, obviously, you should be given this number. It has to be given to you in the problem because you're not doing it yourself. So this number will just appear and it'll say, in the experiment, this much was actually produced. That's your actual yield. The theoretical yield, you have to do some work. The theoretical yield, remember, is the maximum amount that we could produce through calculations. So this is, theoretically, if everything went perfectly, that's how much you would produce. So you have to calculate that, and it will usually be a mass-to-mass conversion based off of the chemical equation, your balanced chemical equation. Once you have those two amounts, though, it's a pretty easy calculation, right? To get the percent yield, you just put the actual yield on top because we know that's going to be a smaller number, right? When we actually do the experiment, we'll always make less than what's theoretically possible. Then you'll put the theoretical yield, the bigger number that you calculated, you'll put that on the bottom, and then you'll multiply by 100. Okay, they should be somewhat close, but honestly, some chemical reactions are pretty inefficient, so it's not uncommon to get percent yields in like the 70%. So don't be too confused if they're not, you're not getting like 90% yield. A 90% yield would be great, but it's still likely to get, even less than 70% still happens in some reactions. Okay. But that's pretty much it for percent yield. Once you have those two numbers, the one just given to you, the actual yield, and after you've calculated the theoretical yield, then you just plug it into this formula. Okay. So on your homework assignment, there's only 3 questions, but here's an extra bonus. If you watch the tutorial video, which I highly, highly recommend, I will walk you through the entire problem of number 1. They can be tricky based on the wording, so definitely watch the tutorial video and do your best to work through the homework assignment.